Let me share my screen. So tonight is February 23rd, 2023, and we'll begin as we usually do with any questions and answers or questions you may have related to um, the content from last week, which would have been the central limit theorem. And we also we didn't finish, we started the discussion of confidence intervals. So do you have lingering questions about either of those topics or any questions in general that I can address for the benefit of the whole? Okay, the rest of the agenda for tonight is we're going to continue the discussion of confidence intervals and sample size estimation. We need to finish the discussion on the Z interval. We're going to talk about T interval, and then we also will talk about the proportion interval. So those are kind of the three topics for tonight. Quiz number 6, which is over confidence intervals and sample size estimation, are due by next Wednesday, which is March 1st. Mini project number 2, which is over confidence intervals, is due by Sunday, March the 5th. And just so you're aware, looking ahead, the midterm exam will open on Monday, March the 6th. And I believe it's scheduled to close on Friday, but let me check. It will close on Sunday, March the 12th. Okay, so you'll have basically a week. But during that week, we will also be continuing on moving forward in the content. I have created a review sheet. It's kind of a paper pencil deal, and there will be an announcement that comes out in D2L on February 27th. It says midterm review sheet or midterm review. And so ideally, hopefully you can have the opportunity to look through or over that document before next Thursday, which is March 2nd, and I can address any questions you may have about that review sheet in preparation for the midterm exam. Any questions on any of that before we dive into tonight's discussion? Okay, so I'm going back to the PowerPoint, and we're going to start with specifically the Z interval for the mean, which we looked at one example at the end of class last Thursday, but I want to go back and kind of hit the high points and pick up with the examples there. So we're talking about confidence intervals, specifically a Z interval for the mean. We know to use the Z interval when we are given the population standard deviation. That is, for us, the biggest clue that we would use the Z interval. If you'll remember, I told you, and it's, I believe, tells you above here, that the Z interval is based on the normal distribution. In the scenario, you should be given the sample mean, the population standard deviation, the sample size, and the confidence level, which is usually stated as a percentage. But again, the biggest clue for us to distinguish whether we're going to do a Z interval, a T interval, or perhaps a proportion interval, is that I know the population standard deviation. The Minitab instructions, whether you have the summary statistics or whether you have the raw data, are on slide 9. The formula for calculating the error bound for the population mean is on slide 10, and that is one of the few manual calculations that you have to do. Manual means you have to use a calculator. Okay, Minitab does not do it for you. We looked at the first example, and then you have the interpretation. We looked at the first example, and so I want to pick up with the second example, which is on slide 13 if you are following along with PowerPoint. And in this problem, it says noise levels at, got a typo there, at area hospitals were measured in decibels. The mean of the noise levels in 84 hospital corridors was 61.2 decibels, and the population standard deviation was 7.9. Find the 99% confidence interval for the true population mean. And again, the biggest thing here, reading through this, a couple of things that I noticed. One is that it's talking about the mean. It says for the true population mean. Okay, so we know we're talking about the mean. It also tells me the population standard deviation. And so again, that is my clue that I want to do the one mean Z interval. And again, the overarching theme here is a confidence interval. So the things that I need to know in order to work the problem is I have to know the sample mean, the population standard deviation, the sample size, and the confidence level. Again, if you don't remember that list is on slide 8. Sample mean, population standard deviation, sample size, and confidence level. All of that information is in the paragraph. It says the mean of the noise levels in 84 hospital corridors. So we had 84 hospital corridors. The mean was 61.2 decibels. And the population standard deviation was 7.9 decibels. And the confidence level is 99%. So I have pulled all of the information from the scenario. Everything I need is given in the scenario. Then I'm going to use, again, I'll make a note here for you. This problem is summarized data. I don't have the list of 84 values that were collected. I have the summary data. On slide 9, then, I want to focus on the statistics, summary statistics process. So I'm going out to Minitab. We go Stat, Basic Statistics, one sample Z. We have summarized data. The sample size was 84. The sample mean was 61.2. The known population standard deviation was 7.9. I go to options. I'm looking for the 99th confidence level, 99%, and we leave it as not equal for the alternative hypothesis. I click OK. I click OK again. And Minitab does the calculations for me. And I'm going to copy this over to my PowerPoint. Okay, hold on. It's gotten really, really small on me. So let me see if I can make it bigger. Oh my goodness. Okay, so I copied it over. You have, it's called descriptive statistics. It tells me that I had 84, tells me the mean, and then the very last piece of information here is my confidence level. 99%, 99% CI for mu. The first number, which would be my lower bound in the parentheses, is 58.980, and that would be decibels. The upper bound, which is the second number in the parentheses, is 63.420 decibels. Okay, so Minitab gives us the upper bound and the lower bound. Then we need to calculate the error bound for the mean. And I'm going to move over to another page. Okay, usually the next question you get is, what is the error bound for the population mean? It's a formula. It is the upper bound, minus the lower bound divided by 2. It is a plug and chug. Minitab has given you the upper bound. The upper bound for this problem was 63.420 minus the lower bound, which was 58.980, and then we divide by 2. Okay, I have to do the subtraction first. 63.420 minus 58.980 is 4.44 divided by 2 is 2.22. So the error bound for the mean is 2.22. Again, that's a hand calculation that I have to do using my calculator. The last step is to do the interpretation. The wording is very important. We estimate with 99% confidence that the true population mean noise level is between 58.980 0.980 decibels and 63.420 decibels. When you're writing your explanation, and I was intentionally doing this, the phrase true population mean, and then you have to enter whatever the variable is. You enter the lower bound, you enter the upper bound. The other piece is you have to put in your confidence level. Now that sentence, if you don't remember the sentence, is on slide 11. On slide 11. Okay. The next question is a little bit different. Okay. It says, suppose scores on pop quizzes in statistics are normally distributed with an unknown population mean and a population standard deviation of 2 points. A random sample of 22 scores is taken and are listed here. So you have a list of 22 scores. Find a 90% confidence interval for the true population mean of statistics pop quiz scores. Now, one of the big differences for this problem as opposed to the ones we've been looking at is this particular problem gives you this list of data. So in this problem, you have the raw data. It doesn't tell you what the population or the sample mean is. It does tell you, and it's important to note that it does tell you the population standard deviation. The fact that I have that population standard deviation is my clue that I'm going to do a Z interval. The other thing that I notice is this problem is talking about a mean. Says we don't know the population mean, and it wants us to find the confidence interval for the true population mean. Now, in terms of the raw data, okay, and if we think about the information we need, normally we need the sample mean, the population standard deviation, the sample size, and the confidence level. Well, I'm given the population standard deviation. It's 2. I have it underlined in green. They tell me that I had a sample of 22 values, but if they didn't tell me that, guys, I can figure it out because I could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. I could count and determine how many I have in the sample. It also tells me that my confidence level is going to be 90%. Now, it doesn't tell me the sample mean, okay? It's not given. It's okay because I have the raw data. Again, the instructions for Minitab for raw data are on slide 9. But I have to enter the data. Remember, you can't do anything in Minitab without the data. And in this case, I have that raw data. So the first thing I have to do is enter the data. So in column 1, I'm going to put stats, pop, quiz, scores. And then I'm going to enter those 22 numbers. 1, 2, 3, 3, 4, 4, 4, 5, 5, 5, 5, 6, 6, 6, 6, 7, 7, 7, 8, 8, 9, and 10. Okay, so I've entered the 22 numbers. I'm going to scroll back up to make sure I don't have something kind of wonky looking. And then I'm going to create the confidence interval. The keystrokes are on slide 9. Stat, basic statistics, 1 sample Z. Instead of summarized data, I have 1 or more samples each in a column. I have the raw data entered into a column. I have to tell it where that data is located. I have it all in column 1. The known population standard deviation was 2. That was given in the problem. My confidence level was 90%, and we always use not equal, meaning it's something other than what we say. I click OK and OK again. And again, Minitab gives me the numbers. Okay, let me add in a slide here. Now, notice, come on now, that in our results, it tells us we had 22 values. Minitab, should you need it, has actually calculated the sample mean. Now, the question may or may not ask you for it, but it has calculated the sample mean. The sample mean for that raw data was 5.591. Okay, this is your sample mean that wasn't given in the problem. If you needed it, Minitab has calculated it. Our confidence interval, again, is here at the end, 90% CI for mu, 90% confidence interval for the mean. The first number is our lower bound. So the lower bound is 4.890. The upper bound is 6.292. Again, I'm reading those results directly from the Minitab output. I then have to use the formula and my calculator to calculate the error bound for the population mean. It is the upper bound minus the lower bound divided by 2. So my upper bound was 6.292. Upper bound was 4.980. And then I'm going to divide that answer by 2. So I use my handheld calculator and do the subtraction. 6.292 minus 4.890 is 1.402. Divide that number by 2. I get 0.402. 6.701. That is the error bound for the population mean. Lastly, we write our conclusion, and we would say, we estimate with 90% confidence that the true population mean statistics pop quiz score is between 4.890 and 6.292. So roughly it's between 5 and 6. Questions? Okay, I'm going to skip the next example. It's another raw data one, and go down to sample size estimation. It's important when you're collecting data that you collect enough data. I mean, we don't want to collect just one item or one piece from one person, or using only 5 is not necessarily appropriate, or 10 or 20 or 30. We need to make sure we collect enough, and the more data we have, the better our estimation is going to be. So when we're thinking about confidence intervals, how accurate do I want to be? We can set up or determine a particular margin of error or a particular error bound for the mean. And then using that desired, that wanted margin of error, along with the population standard deviation and a critical value based on what level of confidence we want to have, we can determine how many items we need to collect. How many pieces of data do I need? Can I get by with 10? Or do I need 20? Or do I need 30? Or do I need 50? So the formula that you need for calculating the sample size is here in the middle of the page. N will ultimately be your sample size. Sigma is your population standard deviation. M is the margin of error that you've set. And then Z is actually Z. And then as a subscript, it's alpha divided by 2. That's your confidence level. And those values are going to be given to you in a table form. It depends upon the level of confidence. Do you want a 90%, 95%, 99%? You could really do any of these listed here. The ones that are bolded are the ones we use most often. The reason it's Z is, again, we are connecting the confidence interval to the normal distribution. Alpha divided by 2, we're simply saying that our value is not equal to a particular value. So it means it could be less or it could be more. So I have 2 different options. So I have to divide that level of confidence, or that significance level, by 2. It doesn't really matter because you're going to read whatever values on this table. But again, I wanted you to be aware of why we're reading that value. You take all of those values that you'll get in the problem, plug them into this formula, and get an answer. And guys, for this, in this case, to ensure that you have enough data, enough people, or enough items in the sample, you will always round up, regardless. If it's not a whole number, you will automatically round up. Okay, again, the tables for Z, or the values for Z, are given on slide 19. They're also given in the header or at the top of the page on the midterm exam, so you do not have to memorize them. So let's look at number 20, or slide 20. It's an example of finding the sample size. It says, suppose scores on exams in statistics are normally distributed with an unknown population mean, a population standard deviation of 3 points. How many scores would the professor need so that a 90% confidence level would have a margin of error of 0.5 points? I want to basically set it up so that I collect enough data so that my values would only be off by about half of a point. Okay, so again, thinking about the information, reading this problem, it asked me how many scores. So it's asking me about the sample size. For the sample size, my formula is N equals the critical value for Z times the standard deviation divided by the margin of error, and that whole thing is squared. So to work the problem, I need the population standard deviation, the margin of error, and my critical value. The population standard deviation is given in the problem. In this problem, it says, and I'm going to underline it for you, the population standard deviation of 3 points. So it's 3. The margin of error is also given. It says, again, let me underline it. Margin of error of 0.5 points. So it is 0.5. My critical value is also, it's not given, but I do need to note that it's based on the confidence level, and the confidence level in this problem is 90%. So I go back to the table on slide 19 and I locate 90%. The critical value at the 90% confidence level is 1.65. So my critical value is 1.65. You have to find that in the table, but the table will be given to you. I then have all 3 of those numbers that I need, and so I'm going to plug and chug into the formula. I have my critical value of 1.65 times the population standard deviation of 3 divided by the margin of error, which is 0.5, and then I'm going to square that value. I'm going to walk it through. I would do the multiplication in the numerator first. So 1.65 times 3, the critical value times the population standard deviation. Then I would do that value that's in the numerator divided by the margin of error, which is 0.5. So that gives me 9.9. And then I'm going to square that value. When I square it, I get 98.01. And I would automatically round up. I would need to survey 99 scores in order to have a margin of error of 0.5 points at the 90% confidence level. I need to have or gather 99 statistics exam scores if I want to have a 0.5 margin of error at the 90% confidence level. Guys, it's straight, flat out plugging into the formula to determine how many I need. How many should I have in my sample? Questions before I do another one? All right. This one says, a researcher is interested in estimating the mean monthly salary of sports reporters in a large city. She wants to be 95% confident that her estimate is correct. Assume the standard deviation is $1,100. How large a sample is needed to get the desired information and to be accurate within $150? Again, it's asking me how large of a sample. So again, the question itself is asking me about the sample size. I am told the standard deviation. I should say the population standard deviation. Again, our formula is N equals our critical value times the population standard deviation divided by the margin of error squared. So I need to identify the population standard deviation, the margin of error, and my critical value. My critical value is based on the confidence level, and this says she wants to be 95% confident. So skimming back through the problem, it says the population standard deviation is 1,100. We want to be accurate within $150. I'm going back to slide 19. This time, I'm looking for the 95th percent. Okay, 95th percent confidence level. So I find 95%. So my critical value is 1.96. My critical value is 1.96. At that point, it becomes a plug and chug. I have my critical value of 1.96 times the standard deviation of 1,100 divided by the margin of error, which is 150. and then I have to square it. Again, I'm going to do the multiplication within the numerator first. So I have 1.96 times 1100 is 2,156. That value is then divided by the margin of error. So 2156 divided by 150 is 14.373333, repeating, and then I'm going to square it. Squared, I get 206.5927111. We always round up. So if I round up, this would be 207. I would need to gather information on 207 sports reporters in a large city and determine their monthly salary. Okay, questions? Okay, that finishes the discussion of Z. We're going to move over to T. I think this is the T. Yes, this is the T. The difference between the Z interval and the T interval is that with the T interval, we do not know the population standard deviation. What we do know is the sample standard deviation. So if I do not know the population standard deviation, but I do know the sample, that is the kind of the red flag or the clue that I need to do a T. We have to make or check to see if we have the same two conditions as we had before. Are we dealing with a simple random sample? And is our sample size greater than or equal to 30, or is the population normally distributed? Again, for us, those two assumptions are usually made or are already embedded in the problem. If you were doing this kind of from scratch from the beginning, you would have to do that. The scenario will give you the sample mean, the sample standard deviation, the sample size, and the level of confidence. And these problems can be presented the same way as we had before. You can either have summarized data or you can have raw data. The difference is with the Z, as I mentioned earlier, we're relating the confidence interval Z to the normal distribution. For the T, we are relating the T interval to the student's T distribution, which has some of the same characteristics as the normal distribution. It is a continuous probability density function. It is also symmetric about the mean, and it is bell-shaped. So it has a lot of the same characteristics. The difference is, and I'm going to draw it this way intentionally, okay? You still have your horizontal number line. You have your continuous symmetric bell-shaped distribution with the mean in the middle. The difference is that the t distribution does not taper off as fast. It does not taper off as quickly as the normal. So what that means is as you get out into the tails in the ends of the student t distribution, there's more area. There's more area in the tails. And quite honestly, this particular distribution was created or initially developed to use with small samples. Most times with the student's T, our sample size is going to be less than 30, or what we call a small sample. It was developed actually by a German who worked for the Guinness Beer Company. And they would take samples of the beer to determine quality control. But they would only take one or two. They didn't sample a lot. And so one of the workers realized that the normal Z distribution didn't really work for those small samples. And so he began working on this particular distribution. When the company realized what he had done and what he had discovered, they would not let him publish that information to share with the world because they considered it proprietary information. So they wouldn't let him publish it in his own personal name. So he chose a pseudonym, much like Mark Twain is a pseudonym for Samuel Clemens. He chose the pseudonym Student, and so that's why it's called the student's T distribution. But the T interval is related to or uses the student's T distribution. And again, the primary difference is, again, that it doesn't taper off as quickly so that I have more area in the tails. From that point, pretty much the process is the same. The command does change slightly in Minitab. We use the one sample T option instead of Z. Again, you can do it with summarized statistics, or you can do it with the raw data. So those Minitab instructions are on slide 4. You still have to manually, with a calculator, determine the error bound for the population mean. It's the same formula. It hasn't changed. It is the upper bound minus the lower bound divided by 2. The interpretation of the T confidence level is the same as it was before. The wording is the same. We estimate with blank % confidence that the true population mean variable is between lower bound and upper bound. So pretty much everything stays the same except for the Minitab command. I know that I'm going to use this one because I do not know the population standard deviation. But the process itself is pretty much the same. So let's take a look at an example. It says, suppose a committee, let me get a blank slide in here. Suppose a committee is studying whether or not there is a waste of time in our judicial system. It is interested in the mean amount of time individuals waste at the courthouse waiting to be called for jury duty. The committee randomly surveyed 81 people who recently served as jurors. The sample mean wait time was 8 hours with a sample standard deviation of 4 hours. Construct a 90% confidence interval for the population mean time wasted. Now, again, a couple of things to note. It says calculate or construct for the population mean time. So we're still talking about a mean. It tells me the sample mean wait time was 8 hours and the sample standard deviation was 4 hours. And I had 81 people surveyed. Notice nowhere in this paragraph does it say anything about the population standard deviation. So there's no info on the population standard deviation, which is my huge clue that I'm not going to do a Z. What I do know is I know the sample standard deviation, which is my clue that I am going to do a T interval. And again, the T interval is associated or connected to a mean. Above, I had listed out the things I needed. In order to work the problem, I need the sample mean, I need the sample standard deviation, sample size, and the confidence level, all of which are given to me clearly identified in the problem. If you will carefully pay attention to the words. So it says in the third sentence, the committee randomly surveyed 81 people. So my sample size was 81. The sample mean was 8. The sample standard deviation was 4. And we're doing a 90% confidence interval. Everything I need is given in the problem. Please do not overthink this. I'm going out to Minitab. If you need it, the keystrokes are on slide 4. I go Stat, Basic Statistics, 1 sample T. I have summarized data. I need to enter my sample size, which was 81. I need to enter the sample mean, which was given in the problem. And let's see, I got it written down here. Sample mean was 8. Standard deviation was 4. Then I go to options. I'm doing a 90% confidence level, and we leave it as not equal for the alternative hypothesis. I click OK. I click OK again. And I get the results. Now the results look very much exactly like what we had for the Z. Okay, for what I had for the Z. Excuse me, I'm on the wrong one. Okay, but I used the different command to do the T. Okay, I used the command to do the T. Okay, so what I need is again out here at the end. I have the 90% CI for mu. Again, the first number in the parentheses is the lower bound. Okay, that hasn't changed. So the lower bound is 7.260. The upper bound is the second number and is 8.740. I just write those down. I do have to calculate the error bound for the mean. It is the same formula that we've been using. It is upper bound minus the lower bound divided by 2. That has not changed. Again, it is a plug and chug. I plug the numbers in. Upper bound first. Okay, so I have 8.740 minus 7.260, all divided by 2. Again, you have to do the subtraction in the numerator first. So I have 8.740 minus 7.260, which is 1.48. Divide that by 2. So that is 0.74. So the error bound for the mean is 0.74. Finally, we write our conclusion. So we would write, we estimate with 90% confidence that the true population mean wait time for jury duty is between 7.260 hours and 8.740 hours. Questions? Again, it's not really new. We're just doing it with a different command with different information because we do not know the population standard deviation. I can also be given the raw data. So if I look at this one, it says, you do a study of hypnotherapy to determine how effective it is in increasing the number of hours of sleep subjects get each night. You measure hour of sleep for 12 subjects with the following results. Construct a 95% confidence interval for the mean number of hours slept for the population, which is assumed to be normal, from which you took the data. So again, the problem itself is talking about the mean. There is absolutely no mention of the population standard deviation. This problem doesn't even give you the sample standard deviation, but it doesn't give you the population either. So in this case, it seems weird because I don't have either. But remember, if I have the raw data like I have here, I can calculate the sample mean and the sample standard deviation. It's not given in the problem, but because I have this raw data, Minitab will do it for me. So it's okay. I do know, I'm told in the problem that, because remember, to work the problem, I need the sample mean, the sample standard deviation, the sample size, and the confidence level. Well, it does tell me again that I have 12 values, but if I didn't know, I could count these up just like we did before, and it tells me to do a 95% confidence level. Again, the mean and the standard deviation for the sample are not given, but Minitab will do it for me. I need to put the data into Minitab. Okay, I'm going to use column 3 this time, and this is hours slept. Okay, so we have 8.2, 9.1, 7.7, 8.6. Whoops, I didn't type something right. 8.8, come on. 8.6, 6.9, 11.2, 10.1, 9.9, 8.9, 9.2, 7.5, and 10.5. And I have 12 values. And again, let me kind of make sure I didn't do anything real wonky. Okay, so then again, we do not have the population standard deviation. Therefore, we have to do a one sample T. Okay, so it's stat, basic statistics, one sample T. This time, my data is in a column. I have one or more samples, each in a column. I have to indicate which column. This one is hours slept, so it's in column 3. Options. We're doing a 95% confidence level. The mean that is always not equal. I click OK. I click OK. And again, I get all of the information. Let me copy it over here. Okay, so if you'll notice, when you get these results, if you need it, Minitab has calculated the mean for the sample. It was 8.983. It has calculated the sample standard deviation if you need it. But ultimately, what you really need, because you're looking for that confidence interval, is this 95% CI for mu. My lower bound, which is the first number in the parentheses, is 8.163. The upper bound is 9.803. You do have to manually, using your calculator, calculate the error bound margin. Again, it is upper bound minus lower bound divided by 2. So I have 9.803 minus 8.163 divided by 2. So I have 9.803 minus 8.163, which is 1.64 divided by 2 is 0.82. The error bound for the population mean is 0.82. And then you write your conclusion. We would say, we estimate with 95% confidence that the true population mean number of hours slept is between 8.163 hours and 9.803 hours. Questions? We do not do sample size estimation for t-intervals. Okay? We do not do sample size estimation for t-intervals. Okay. I want to recording, and we have one topic left, and we're going to talk about confidence intervals related to proportions. The difference in these problems is you're going to have a proportion or typically a percentage. Let me change that to a different color. Okay, another way to think about proportions is you have a percentage. Whereas before, you had the mean. Okay, the confidence interval for the mean with the known population standard deviation was the normal distribution that we talked about at the beginning. We just finished talking about the confidence interval for the mean with an unknown population. The process, the procedure that we use is the same for a proportion. It's just that the formulas are slightly different. It actually kind of forces you to do a little bit more calculation. But your first question has to be, how do you know you're dealing with a proportion? Well, one is that when you're talking about a proportion, our underlying distribution is the binomial instead of the normal or the student's t. Additionally, in the story, there's no mention of the word mean. So that's really the big clue. Okay. So again, the formulas here are a little bit different, and you have to do a few hand calculations. You have to be told somewhere in the problem the number of trials. How many times are you going to do the problem? Are you going to collect? Are you going to do it 20 times, 30 times, 50 times? And then you also have to know the probability of success. Remember, probability of success is you get what you want. What's the chance you get what you want? And again, to work these problems, we have to do a few hand calculations for ourselves because we have to actually calculate the point estimate for the proportion, which is called P prime. Okay. You also have the P, which we just talked about. Just if it's plain P, that is your probability of success. That probability of success will likely be given in the problem. But your point estimate, this is like, the point estimate would be like your sample mean. You want to relate it back to that. Okay. It's actually called the sample proportion. We may have to calculate it. It is the number of individuals in the sample who are in this category we're interested in divided by the sample size. You also have those that are not in the sample, okay, which is Q prime, and that's 1 minus P. Instead of calling it the error bound for the mean, we call it the error bound for the proportion because we're talking about a proportion now instead of a mean. So the abbreviation changes from EBM to EBP, error bound for the proportion. The scenario is going to give you the number of successes, the sample size, and the confidence level. We only do one type of these where you have summarized statistics. And specifically, when we do a proportion, we use the Z interval. Now, we're doing a Z interval for proportion, not the mean, but the command is the same. We just have different information to enter. Okay. The Minitab instructions is called a one sample proportion. And the other thing to note is we will always do a normal approximation. But the keystrokes for Minitab are on slide 5. The formula for the error bound of the proportion is the same. It's still the upper bound minus the lower bound divided by 2. Everything is pretty much the same except for the information that you have initially and what you have to enter into the computer or into Minitab. Even the interpretation is written the same except for we say total true population proportion, because again, we're not talking about the mean. We're talking about a proportion. So again, it's not really a majorly new concept. We're just building on what we already know. So let's look at an example. And I'm going to add a slide in. It says, suppose that a market research firm is hired to estimate the percent of adults living in a large city who have cell phones. 500 randomly selected adult residents in this city are surveyed to determine whether they have cell phones. Of the 500 people surveyed, 421 responded, yes, they have cell phones. using a 95% confidence level, compute a confidence interval estimate for the true proportion of adults residents who have cell phones. Okay, so in this scenario, again, nowhere, there is no mention of mean. In fact, several times throughout the problem, it says percent or proportion. Estimate the percent. Compute the true proportion. Okay, so even in the problem, it's using words like percent and proportion. So those are the clues that I'm going to do a proportion interval, which is based on Z. The information I need in order to work the problem is I have to have X, which is the number of successes. I have to have N, which is the total number in the sample size, and I need the confidence level. So if I read back through the problem, it says 500 residents are surveyed. So my sample size is 500. I continue on. It says, of the 500, 421 responded, yes, they own cell phones. So the number of successes was 421. And then my confidence level is 95%. So I have everything I need. I'm going out to Minitab. Stat, basic statistics, 1 proportion. This is a proportion. I have summarized data. I need the number of events. That is, how many times did you do it? We surveyed 500 people. Oh, wait, I'm sorry, number of events. Events are how many successes? That's 421. Number of trials was 500. I surveyed a total of 500 people. Those are considered the trials. My event is that I get a yes, and there were 421. Options, we're doing 95. It's not equal, and we will always do a normal approximation because we're basing it off of the Z distribution, which is the normal distribution. So we will always do a normal approximation. I click OK. I click OK. Copy. Wrong one. Sorry. Okay, so I put all that information in, and let me paste this. Okay, so it shows us we had N in our sample. The event was 421. This number here, if you need it, this number here, sample P, is your P prime. Okay, it's figured your sample proportion for you. Minitab is so nice because it does most of the work for you. What you need again is this value out here at the end. And let me see if I can pull this apart. The first number in the parentheses is your lower bound. The second number is your upper bound. So my lower bound in percent form or in decimal form, the lower bound is 0.810030. The upper bound is 0.873970. I'm copying them directly from Minitab. I then need to calculate the error bound for the proportion. Error bound for the proportion. It's the same formula though, guys. It's upper bound minus lower bound divided by 2. So we would have 0.873970 minus 0.810030 divided by 2. You have to do the subtraction in the numerator first. So I have 0.873970 minus 0.810030. That is 0.06394. I have to divide that by 2. So my error bound for the proportion is 0.03197. There's my answer. Now, I don't recall D2L, when you're working on your homeworks, may ask you to round to 2 places or 3 places. I honestly don't remember right now, right off the top of my head. We then write our conclusion like we've been doing all night long. We would say, we estimate with 95% confidence that the true population proportion of adult residents who own a cell phone is between 0.810030 and 0.873970. Please don't overthink it. It's the same process. You're just applying it to a proportion, which changes the command that you need in Minitab, and that command is on slide 5. Okay, we do sample size estimation for the proportions. Okay, we do sample size estimations. Again, you have to have those critical values. They're the same critical values we had earlier. The table will be given on the midterm. If you need it when you're working homework, it is here on slide 12. Now, the formula itself looks a little bit more wonky, okay? Looks a little bit more wonky, and I don't think I wrote it down, so let me write it down real quick. Okay, so just to kind of give you some explanation, the Z alpha divided by 2, that's going to be your critical value. And it's going to come from the table. And notice that you have to square that number. EBP is what before we were calling the margin of error. And was represented by that lowercase m. Again, it's just a different notation because we're dealing with proportions. Okay, the P prime is your probability of success, that you get what you want. Q prime is your probability of failure, and it's 1 minus P prime. So we can get all the information. It's going to probably be given to us in the problem, or we have enough to figure it out, and then we just plug and chug. It's just a matter of understanding the formula. Okay, so let's look at an example. It says, suppose a mobile phone company wants to determine the current percentages of customers aged 50 plus, who use text messaging on their cell phones. How many customers aged 50 plus should the company survey in order to be 90% confident that the estimated sample proportion is within 3 percentage points of the true population proportion of customers aged 50 plus who use text messaging on their cell phones? Okay, so there's a couple of issues here with this problem. Okay, notice that it doesn't talk about my sample proportion. Okay, there's no mention of this many people age 50 or older use text or they don't use text. There's no mention of your probability of success. Oops. Which would be P prime. When you have that scenario, okay, when you have that scenario where there's no mention of that probability of success, the default is to use P prime is 50%. Okay, is to use P prime is 50%. And if you think about it, that should make maybe some sense to you, because when you survey those people, they're either going to say, yes, I use text, or they're going to say, no, I don't. So there's 2 options. So you have a 50-50 chance of getting a response of yes. So if there's no mention of it in the problem, we use the default of 50%. So I'm going to have to do that in this problem. If P prime is 50%, then my probability of failure is Q prime, which is 1 minus P prime, okay? So I would have Q prime, or excuse me, I would have 1 1 minus the 50%, which is 50%. So for this problem, P prime and Q prime are both 50% because there's a 50% chance they're going to say, yes, I use text, or there's a 50% chance they're going to say, no, I don't. Looking at the other information in the problem, it tells me that the estimated sample proportion is within 3 percentage points. That is the EBP. I'm error bound for the proportion. I want to be within 3 points. And the other piece that I have that's important is I'm doing a 90% confidence level. Okay, so I got to take all that information. Minitab doesn't do this. This is a plug and chug. So I've got to plug and chug into the formula. And let me write the formula down. Okay, our formula is N equals the critical value squared times the probability of success times the probability of failure divided by the error bound proportion squared. Okay, so from the other slide, we know that P prime is 50% by default. Q prime is 50% by default. The error bound proportion they gave me was 3. So I need to identify my critical value, which is based on the confidence level, and my confidence level was 90%. So I'm going back to slide 12 to look at this table. 90%. Here's 90%. So my value is 1.65. So my critical value is 1.65. So I have everything I need. I'm going to plug and chug into this formula. So I would have 1.65 squared times the 0.5 times 0.5 for failure divided by my 3 points squared. Now, let me see if I can get my calculator to pull up. Sometimes it's slow and doesn't want to pull up, but let me see if I can, so that I can show you these calculations. I would do everything in the numerator first, and then everything in the denominator, and lastly, do the division. And maybe this will come up in just a minute. Okay, it doesn't want to come up. Let me see if I can go this way. I knew sometimes it doesn't come up. Okay, looks like it's not going to come up. So I'm going to use my handheld, and I'm going to type everything on the top row into the calculator first. So I'm going to do 1.65 squared times 0.5 times 0.5, which gives me 0.680625. And then I'm going to divide that by 3 squared. I can do 3 squared in my head. 3 times 3 is 9. I'm going to divide that number by 9. Something ain't jihading. Did Miss Ralston write the formula down right? Three points. Okay, hold on, guys, because I'm getting a weird number. I'm getting like a decimal number, and that it could be that. 3 percentage points. Okay, that's I think where I'm making my mistake. Okay, this says 3 percentage points. So if this is 3%, okay, it's 3 percentage points. So that value is 3%. And if I convert that to a decimal, that's 0.03. I think that's where Miss Ralston's made a mistake. I'm entitled to one. Okay, so I would have 0.03 squared, 0.03 squared, 0.03 times 0.03 would be 0.0009. Okay, so 0.680625 divided by 0.0009 gives me N equals 756.25. We always round up. So I would have to survey at least 757 people aged 50 or older. And again, the mistake that I made was I missed this word percentage. It said 3 percentage points. So that's really 3%. I do apologize. I missed it. Three percent. And I could have swore I had another example, but I don't see it here. Okay, questions. Okay. Hold on again.